Hi there, this is Mrs. Tellas. We're going to start chapter 2 today. We'll be doing chapter or section 2.1 where we interpret inequalities from English statements and then graph them as well. So that's our plan for today. So just a review, looking at the inequality statements, these are all inequalities. So last chapter we focused on equations. Everything had an equal sign. And in this chapter, we focus on the greater than and less than symbols. So if you'd like to pause and copy these down, that's a really good idea if you don't have them memorized. So this first inequality symbol is greater than or equal to. Greater than or equal to. The second one here is less than. Okay, this one's obviously equals. You know that one. We used it with equations. This one is less than equal to. And this last one over here is greater than. There's greater than. Okay, so we're going to be using these again and again. All right, so I'm going to have these graphic organizers in class. So you don't really need to copy this unless you're virtual. Actually, what I'll do is I'll put the PDF of it on the website as well, so you don't have to copy it either. But notice we're looking for the word is on all of them. And then each of them fall into specific categories, whether it is less than, greater than, this one's greater than equal to, and less than equal to. Okay, so you kind of see those at the top there, is less than, is greater than. So we'll be using this again and again, and you'll be able to use it on your assessments. All right, so first thing we're going to do is going to take the sentences and change them to inequalities or math looking. So the number W, and remember anytime it says number, we use a letter. So we're going to do W. The word minus is minus 3.5. The is less than or equal to is the inequality symbol. So I put less than or equal to and then negative 2. Okay, the next one, 3 is less than, I know that's the inequality because it says is less than a number n, so I put n, and then plus 5. Okay, let's do this one. So 0 is greater than or equal to, twice a number x, so 2x plus 1. So I'm kind of like decoding it like it's a foreign language and I'm changing it to math. That's really what I'm doing. All right, so now you take a second, pause, and try these and see if you can come up with them. Try them on your paper. All right, so it says a number x, so I start with x, is no less than negative 7. So if I'm not sure what is no less than is, I go look at the graphic organizer. And is no less than is right here. So I'm going to use greater than equal to. That's how I'm going to use that graphic organizer to help me. So when I'm not sure what the inequality is, I can go look on the little paper. So twice a number would be 2y, because it says I have to use y. Is below is less than, and then 20. Number 6, 7 minus a number. It doesn't say what I'm going to use, so I'm going to use x. Is at least, is greater than equal to, and 19. And again, if I'm not sure what that is, I go look at my little graphic organizer to help me. And then a number divided by 25 would be represented like a fraction. Is no more than would be less than equal to, and negative 15. So I hope you got a couple of those right. I hope you got all of them right. Hey, if you didn't, I hope you see what went wrong so you can get them right the next time. Okay, so we're going to do the graphing now. So you can see the picture here that goes with less than 2, x is less than. See how it has an open circle and it's shaded to the left? And this one also has an open circle and it's shaded to the right. This is x is greater than 2. This is x is less than or equal to 2. Notice how it has a closed circle, or we colored it in. And this one is x is greater than or equal to 2. So again, it has a closed circle, and it's shaded to the right. So you can see the ones that have the equals here and here, you color in those circles, and they're represented as closed, and the ones that don't have that are open. What that means is that 2 and the top 2 are not part of the solution. 2 is not part of either of their solutions, and down here 2 is part of the solution. All right, an open point is an open circle not colored in, and a closed point is a closed circle colored in. And the closed have the equals and the opens don't. So if I'm graphing this, I make myself a line, and I put the number on the right side right in the middle. Then I go up 2 and back 2. There's my number line. All right, so it's got a greater than. So this is open. So on 5, I put an open circle. And it's greater than. So the numbers that are bigger than 5 get shaded. So I shade to the right, and I color in the arrow showing that the solutions go all the way to infinity. So you can tell by the picture what's a part of the solution set. So 6 is, 7 is, 8, 9, 10, a million is. But 5 is not because it's open. 4 and 3 are not. 2 isn't. 1 isn't. 0 isn't. None of these are a part of the solution because they're not in the shading. So if we do the other one, we put 0 right in the center. So I'm going to go up a couple and back a couple. It's a closed circle on 0. And again, it's greater than, so I'm shading to the right because those numbers are bigger than 0. And that's what my graph looks like. 0 is a part of the solution. So is 1, 2, 3, 4, 5, on to positive infinity. So those are all part of the solution. Anything on the other side that's not shaded is not part of the solution. Okay, and then the variable's got to be in the front to do this, to graph it. So if I flip everything, I flip the x and the 6's position. That means less than also have to flip to greater than. So now you hit pause and try to graph this on your own. So 6 would go in the center. It would be open because there's no equal sign, and I would be shading to the right. Okay, and on this one, again, x is not in the front. The variable is supposed to be in the front, so I change their positions, and I change less than equal to greater than equal to. So I put -2 in the center. I close it up. Let's see, getting bigger would be -1, 0, and getting smaller would be -3, -4. And again, I'm shading to the right. And all of these examples seem to shade to the right because they're greater than, but all graphs don't do that. That's just coincidence, just letting you know. All right, your turn. You try this. You've got 3 of them here. Press pause and try all 3. Draw the line on your paper, put the -3 in the center, decide if it's open or closed and which way you shade. Go ahead and give that a try. All right, so I'm going to put -3 right in the center. It's a closed circle. It's closed because it's got this equal to part right here. Okay, so getting bigger would be -2, -1. Getting smaller, -4, -5. And it's less than or equal. So that means I shade the left side because those numbers are smaller than -3. This is in the wrong order, so I switch x and 2. Less than becomes greater than. 2 goes in the center, and it's open. So 3, 4, and back 1, 0. This is an open circle because there's no equals, and it says greater than, so I shade to the right. Okay, and the last one I hope you tried, we put 0 in the center, so up 2 and back 2, it's open, and I'm shading to the right because it's also greater than. Okay, I hope you got those right. Good job if you did. Okay, I've got some more of them here. This one's pretty much the same thing. Here we have a decimal, and it's in the wrong order. Let's do this one. So we'll switch g and 1.4, and greater than equal to becomes less than equal to. So right in the middle, 1.4. It's a closed circle. So I think I'll go up 2.4 and 3.4. and back 0.4 and negative 0.4. That works. It's closed because it has the equals, and then I would shade left. That one's kind of different with the decimals. Okay, here we're going to start solving a little. Well, 1 minus 2. 1 minus 2 is negative 1. So we just had to do a little math there. So that would be open on negative 1 and shaded to the left. Okay, and then the square root of 36 is 6. So V is greater than or equal to 6. So 7, 8, back. It's closed, and I'm shading right because it's greater than. 7 and 8 are bigger than 6. All right, let's do this one. It says write an inequality that represents the graph. So this is going backwards. So I start with an X, and since the dot is on negative 6, I put negative 6 over here. Since the dot is a colored in dot, it's closed, I put the equal sign. And then I notice that numbers that are bigger than negative 6 are shaded, so it's greater than. Okay, another way I know that is because if you look at greater than, you can compare. See how the arrow that's colored in is the same as the greater than symbol? You can see that that's the same thing. So that's the inequality. And then let's talk about whether something's a solution or not. So -1 is right here, and 1 is part of the shading. So yes, 1 is a solution. So yes. Is -8 a solution? Well, -8's right here. It's not part of the shading, so it's not a solution. 1,234 is way down here on the right side, way off the board, but it's part of the shading because the shading goes to positive infinity. And then -80 is way over here this way. It's not part of the shading, so that's no. Let's look at number 12. It says the graph shows the height restrictions h in inches for 2 rides at an amusement park. Write an inequality that represents the height restrictions of each ride. So it looks like on ride A, 48 inches is the cutoff. And you can be 48 inches because it has it colored in. So it's 48 inches or bigger. So that would be greater than or equal to. And on ride B, this must be a little kid's ride because we've got X and 52. 52 inches is the cutoff. It does not include 52 because it's open. And to the left, it's smaller is shaded, so it's less than. So those are my 2 inequalities. Okay, that's all I have for you today. Thank you for listening. I hope you understand. And if you don't, give me an email or jump on the conference. Thanks. Bye.